And so we'll just keep updating ESI as we go along here. And so in the beginning, what we really wanted was the address of where the 1 is, because these are all D words, right? So we have an array of double words here. And then here we want to get the address of the 2. But that's fine, because given what we've done in terms of initialization, we can just directly build off of that as far as updating. Because we talked before about the difference between D words and bytes and words in terms of how you're going to iterate through those, because we know that D words are increments of 4, words are increments of 2, and then bytes are increments of 1. And so we just need to take that into account, right? So this would be a little bit different if this array were size word or size byte, but in this case, since it's size D word, we're just going to go ahead and add 4 to the current value in ESI to get ready for the next step. Or if this were loop, then to get ready for the next iteration of the loop. Because we're doing the same thing as a loop, right? But we're just doing it for now manually without using a loop. And then we'll later see how you could do this in terms of a loop also. But we're just going to add 4. Now it's going to be storing the address of the 2. And then we keep going in a similar fashion. So now that we've updated our ESI, we just need to do another accumulate statement. So EAX, in this case, equals its current value plus the second, right? Which if we think in terms of index numbers, the second element would be at index 4, since it's an array of D words. So EAX equals its current value plus whatever is at index 4, which would be 1 plus 2 equals 3. And so now we get the general idea of this, because it's just going to keep going in the same way until we get all 5 elements and get the final sum in EAX. And so the idea here really is that after we initialize ESI, right? And so up here we did really 2 initializations. We wanted to make sure EX was 0 since that's our accumulator, and we wanted ESI to be the starting address of the array. But then after that, we just are basically alternating between adding EAX and dereferenced ESI, and then adding 4 to ESI to update it, right? We're just going back and forth really between those 2 statements. And now we're talking about the third element, so that would be at index 8 here, or the 3. And then EAX's current value is also 3. And so that gives you an idea of how we'll use the offset operator, because a lot of times we will end up using things like register ESI or EDI and have it act like a pointer. Now we'll see that in general, there's different ways that you can use these registers, and the way that we're using it here is what we sometimes call indirect operand. Because we've talked really about a couple of different types of operands throughout this chapter. We talked about direct memory operands and as well as direct offset operands. And remember the distinction between those two is when we talk about direct memory operands, that just means when we're referring to the variable name by itself, like move EAX array 1. That's what we mean by direct memory. When we say things like move EAX array 1 plus 4, where there's an offset that you're adding to it, we call that direct offset operand. And those are both directly involving the name of the variable. Now here, we are making, right, several references to memory, right? Anytime we refer to bracket ESI or dereferenced ESI, we're referring to memory. But we're doing it, of course, without directly referring to the name of the variable. So we call that indirect operands because we're indirectly referring to locations in memory, but we're doing it on an indirect basis, in this case, using just the register. The idea being that since ESI is always going to be storing an address related to array 1, meaning the address of one particular element at a time of array 1, that we can then refer to that array just with ESI and the dereferencing operator, which is the bracket. So we call that indirect operands. And so we can do that all the way up into till the end here when we get the sum of all 5 elements. Okay, so after the 4th one, then we're going to be up to 10 for our value in EAX. And then we go one more round here to get that 5th and final value. And again, each time, all we have to do is just keep adding 4. And then we're going to end up with that final value of 15 there. And then just to recap what we've seen so far, at least in terms of operands, we've seen direct memory. That's really the first thing that we saw. And direct memory, that just means that there's no offset. So we're referring to the name of the variable directly, but there's no offset that we're using on top of that. So this would be an example, right, of direct memory. Something like this, whether we do or don't use the brackets, right? So either way, we would still call that direct memory, because we know that the brackets are optional with variable names, but we usually do use them when there's an offset involved. So that's direct memory. And then we've talked about before direct offset. That's where you're still referring to the name of the variable, but there's also some sort of offset, right? So you're relying on that offset to get the actual location that you want to refer to. So things like this are what we mean by direct offset. Indirect is where we're using in this case, a register to act as a pointer. And so similar to our example above, indirect operand just means things like this, where we have one of the operands here being that register in the brackets, which means the register is being used as a pointer. And so those are three different types of operands that we've seen now. And then we saw up here the general idea in terms of how you would start this off. So the starting point would involve the offset operator. That's how we can get that initial address of the ESI. And then from there, we can just, as we saw with the short example here, once we've started off with that, we can then start adding to the value in ESI to change the address as we go along. And you know, that's similar to things also like pointer arithmetic, right, from C++, where you might define your array, define a separate pointer, have it point at the beginning of the array, and then do things like PTR, you know, for example, plus plus to move the pointer up, or PTR minus minus if you're going to move the pointer backwards, right? Well, we're really just doing the same thing here. We're just updating we're actually changing the address in ESI as we're going along with this algorithm. And so we saw here, you know, a way of doing it manually where we're, you know, repeating essentially the same instructions over and over, depending upon how many things that we want to add. But it's the same idea also if we were doing this in terms of a loop, right? So you could imagine things that are going to be happening inside of that loop body. One of them certainly would be the accumulate statement, right? A statement like this, where you're actually building up EAX, and then the other, right, would be a statement like this, where where you're, increasing the value in ESI. And then again, that's really comparable to things like pointer arithmetic in C++, where you initialize your pointer at the beginning of the array, and then use things like the PTR++ to keep moving up. Right, because we're doing something comparable to this, right? If we think in terms of C++, um, where we're using a pointer that we initialized in the beginning to, in this case, the starting address of the array, and then we had our accumulator, which was EAX, and then we're just going along and building it up, right? By referring to that. In this case, ESI was our pointer, but we're doing something like this. The other thing that you could also do in some cases is you could also, for example, have an offset that you refer to inside the brackets. So sometimes we may do things like that, especially if maybe we're just using one pointer like ESI, but maybe on, for example, a given loop iteration, we have to refer to two different locations in the array. Then we can also do things like that. So you can still, even when you're using indirect operands, meaning when you're using the register as a pointer, you can still have an offset too, like ESI +4, for example, or ESI -4, and then in that sense you could refer to multiple elements in the array together, because depending upon what exactly it is that you're doing, with some types of algorithms, you might need to refer to on a given loop iteration, you might need to access multiple locations in the array at the same time. And so, I mean, one way that you could do that potentially would be to use ESI and EDI together, but we could potentially also do it off of just one pointer. The idea being that, for example, if ESI is pointing here on the current loop iteration, and maybe we need to refer to the next element also, Well, the idea is that if ESI is pointing here, then ESI plus 4 would be here. So that still gives us a way in which we can, refer to multiple elements in the array on a single given loop iteration. So we can also have offsets along with the register name inside the brackets also, because sometimes we may need to do that. So things like ESI plus 4, for example, if assuming we're working off of a D word type array is fine, or if maybe we're working off of a word array, then things like ESI plus 2 inside the brackets is fine. So we can also have offset along with the register name as well. So there's different ways that in general we could that we could do this, because another thing from C++ is one thing that we can use in general is things like pointer arithmetic, where the pointer is actually changing. But we can also think about doing things in terms of offsets. Meaning that in general, right, you're familiar with both of these kind of things with C++, where if we've defined a separate pointer like this, where PTR initially points at the beginning of the array, we know that one thing that you can do is change the pointer, move it up and down, for example, throughout the array, which is what this first loop is doing. But then there's also this way of potentially handling it as well, where we keep the pointer still pointing at the beginning, but then we just add, of course, we would need to keep adding a bigger and bigger offset to correctly build up EAX. So in this case, unlike the first loop up here, which we don't need to refer to I really inside the loop body, since the pointer itself is going up each loop iteration. But then here, we're not changing PTR. In other words, we're keeping PTR pointing at the beginning, but we are adding a bigger and bigger offset with the statement here. And then you know from your 110 and 165 that on the C side here at least, the syntax is that we have to have the parentheses there as well to ensure that we do the addition part first before the dereferencing. The idea being we want to take the address in PTR, add i's value to it, and because this is a high-level language, it's also handling some of those low-level details for you, such as the fact that an integer is 4 bytes. So we know that this is really doing more than just PTR plus I, right? Because it's also multiplying really, i's value by 4 also to have this correctly go up in increments of 4. But we're doing all that, and then we're dereferencing with the star operator, and then we can grab that value and add that to whatever's currently in EAX. And so the idea is that both approaches also can work at the assembly level, just depending upon how we want to approach it. Okay, so just again, how we can think about how these things relate to things at the higher levels, meaning C++ level. Um, so we've looked at 3 types of operands, and now a fourth one also does involve register. But the fourth type that we'll look at here, and we call this sometimes indexed operand, the fourth type is still going to be using a register name, but along with the name of the variable. And so the idea is that there's, in general, there's different ways that we can use ESI and EDI. One way that we can use it is as a pointer, which is what indirect operands was about. The other way that we can use it is as an index number. And the idea is if we're going to use it as an index number, so instead of storing an address, we're just going to store a number in ESI, really an offset number. And then the idea is that if we're doing that, then we're still going to need to refer to the name of the variable, right? We're going to have to refer to some sort of variable identifier name in order to be able to grab the data, right? Because certainly we can't just dereference, an integer number. We have to have an address ultimately. So that's yet another thing that we could also do. And we'll see some examples of that as well. So those are both different ways that we can use ESI or EDI. And so we can look at that example that we did previously up here, or we can look at this again, because this was an approach, and the goal here was to add up all the elements in the array and have the sum be stored in EAX, which was acting as our accumulator. But we'll revisit that problem, and we'll look at it in terms of indexed operands. So the difference here is that instead of having ESI store the address directly, if we're going with the indexed operand approach, then it's going to be storing an index number. So instead of saying offset array 1, we could start here with 0. Okay. Now on the accumulate line, meaning the first add EAX instruction, there's a couple of different things that we could do here, right? There's actually a couple of equivalent syntax forms. And both really, if you think about it, are comparable to how you think about this in C++. But one thing that you can do is this. So add EAX array 1 on the outside, and then ESI inside the brackets. So again, that's very similar to using the brackets in C++, where you have the name of the array on the outside and then the index number on the inside, where in this case, the index number is coming from ESI itself. Or we can do it as a plus type expression, which would be similar to something like star on the outside, right? Parentheses, name of the pointer, which could be the name of the array itself, right? And then plus the offset. And the idea is that those two lines are going to be equivalent, right? They both do the same thing, just different ways of writing it out. So you choose one or the other, but again, they're both also similar to C++ type syntax, right? This is kind of like how we usually use the brackets. And then here we still use the brackets, right? Because brackets mean dereferencing. But this is kind of more to the point of what's really happening, that you're taking the address in the array, you're adding the value in the ESI, that gives you potentially a different memory address depending upon what the value in the ESI is, and then you're going to finally dereference that address using the brackets. So in that sense, it's also very close to a direct offset operands, except instead of having a literal value like ARR1 plus 4, now it's ARR1 plus ESI. So, but similar to direct offset operands. So again, both of these are going to do the same thing. And so since ESI is 0, then for now at least, that just means that the first element in the array. We're going to add that to EAX. So like before, EX is going to equal 1 after that first add instruction. And then here, we are using ESI as an index number. Of course, we know how this is different than the high-level language level, because we do have to think about the low-level details, like, is this an array of bytes or an array of words or an array of D words? So, we're still going to be going up in 4s. So we can still, like we did with the indirect operand version of this, we can still add 4 to the value in ESI. It's just, instead of changing it to a different address, now we're just changing it to a different integer number. So that part will be the same. So ESI is now going to be the number 4 instead of the number 0. And then we can keep going in a similar fashion. And then we're done after that point when we get 15. So again, very similar to the previous version of this. It's just now we're using ESI in a different way. So we call this again indexed operands, where ESI is always just storing an integer number. And again, either of these two are fine to use, but you would just choose one of them. And they're both going to do the same thing. So we can either use the version that's similar to how we would use the brackets in C++ with the array name on the outside, or we can set this up as similar to the star notation from C++, where you'd have the brackets on the outside and then you have the plus expression on the inside here. And again, this second version here, it's just a little bit more clear in terms of what's really happening, that you are doing this addition between the starting address of the array and the integer number in ESI, and then you're going to use that address to dereference with the bracket operators, and that's going to give you the correct value to grab from the array and then add to EAX. But either of these two would work here. And then we just go, like before, we go through the same set of instructions several times to add up, right, in this case, to add up all 5 of the elements in the array. Okay, so now we've talked about a total of 4 different operands with your direct memory, direct offset, indirect, and indexed, where the last 2 of those both involved registers. So for example, indexed was similar to direct offset. It's just you're using a register now as your offset instead of a literal value like 4 or 8 or 12. So we saw that direct memory and direct offset, those 2 did not involve a register. And then indirect and indexed, both of those did involve a register. So now we've seen several different ways of thinking about these, these common, operations, like, for example, adding up all the elements in the array. And we have different ways in general that we can, think about how to handle those operations. And we've seen in particular different ways that we can use registers like ESI and EDI. Now, one thing that we'll look at also in chapter 5 is functions, which we call them procedures at the assembly level. And we'll see that just like, so here we're doing everything still in main, but we'll see at that point that you can also think about the different options there as far as indirect or indexed and so on. One thing we will see when we start talking about procedures is that, and again, procedure is just what we call functions at the assembly level. But when we're dealing with procedures, we'll see that there are some advantages to indirect operands. One of them being that, just like we saw before, one of those was the fact that we don't have to refer to the name of the variable, right? And in fact, out of the 4 types, indirect was the only one where we don't have to refer to the variable, meaning after we've done the move instruction, like move ESI offset array 1, after we've done that initialization, and the rest of the algorithm, right, we don't have to make a direct reference to ARR1 by name. And, the idea is you want to think about things like reusability, right, with procedures. And if we want to have, in this case, a general function that can take any D-word size array and be able to add up all the elements in that array, well, if we use indirect operands, then we can set it up to where the function does not have to refer to the name of the array at all. So that way, regardless of what the array is called, the function is going to work with that array. Whereas, of course, if you're using indexed operands or direct memory or something like that, then you are going to have to refer to, the name of the variable, in this case, the name of the array inside the procedure body, which means it's not going to be as reusable. So we'll, see these things come up again, certainly in chapter 5, but that's one of the advantages also of the indirect operand approach. Of course, it's still a memory access, right? When we think about a statement like this, we have to keep in mind that these aren't really both register operands, because when you put the brackets around it, we know that what you're ultimately doing is you're going to memory and you're accessing that value. So you're still going to have to go to memory the same amount of times, right? But at least we don't have to refer to the variable by name. So we could, even if the array was called ARR2 or something else, you know, that same procedure with that same logic is going to work. Whereas if you did something like indexed operands, then you'd have to refer to the variable name, and so then it's not going to be as general. So we'll see those kind of things come up again when we talk about procedures in chapter 5. Okay, so any questions so far? Okay. Well, so we've seen the offset operator, again, something that's very useful, given that it's going to give us at least one way of getting the address of something. And another operator that sometimes is useful is what's called the PTR operator. And we'll see that it has a couple of different uses as well.